Next lesson is on inequalities 5.6. A little bit boring. We've got a little dolphin down here, however, one of my favorite animals. Inequalities are something that is not equal. If it was equalities, it would be things that were equal. This is something that is unequal. Okay, so you've seen these symbols before. This one here is greater than. Oh, greater than. The one below it is less than. And the way I remember the less than is that it's like an L that's smushed if you look at the symbol. Less than. But these two might be new to you. This one is less than, but it also has an equal to on it. So it's called less than or equal to. And the one right below it is greater than or equal to, as you would assume. So you've only used these in senses like 4 is greater than 1. Okay, true statement, yes. But now we're going to start using it more in an algebraic sense. So x is greater than 2. Well, what can x be if it's greater than 2? Well, it could be 3 or 4 or 5. Could it be 2.1? Yes. Could it be 2.0000001? Yes. It could be anything larger than 2. It could be 2,000. Could it be -5? No. Okay, makes sense? So it's hard because I can't possibly list all these. So the best way to do it is to write it or to draw it. Right here is how you would write it using algebra, all of those answers. Okay, well, what if I said, well, x is less than or equal to 6? Well, what would my list be? Well, if x can be less than or equal to 6, that means it could be 6. It could be 6. It could be 5.9 repeating. It could be 5.6. It could be 4. It could be 0. It could be -9. It could be -1,200. ... In fact, there are infinite solutions for both of these. So again, I write it using algebra. On the next page, I'm going to show you how we draw it. But the big difference here is that x is greater than 2 does not include 2 because it has to be bigger than 2. It's like your mom saying, well, you have to have more than 2 pieces of fruit a day. So does that mean only 2 is okay? No, she said more than 2 pieces of fruit. So that means 3 pieces of fruit or 2.5 pieces of fruit. This one here, x is less than or equal to 6. Your mom said, well, you can have, 6 or less pieces of Halloween candy. So that means that you can have 6 or you can have less than 6, but you cannot have any more than 6. So 6 is my upper limit. Okay, so moving on. If I want to graph it, x is greater than -5. I want to show you in a picture all of the answers for x is greater than -5. By the way, do you like my duck at the bottom? I wish he didn't have a halo around him, a green halo, but he did. There we go. Okay, so there's my duck, and he's showing you how we're going to graph it. So x is greater than or equal to -5. So ask yourself, okay, well, what does that mean? Can it be -5? No, it has to be greater than -5. So can it be -4? Yes, because that's larger. Can it be 0? Yes, because that's larger. Can it be 5? Yes, because that's larger. Can it be 10? Yes, but there are infinite solutions. So the best way to show that would be using algebra or on a picture. So I said x has to be larger than -5, so I find -5 on my number line. But because -5 is not included, I'm going to put an open circle on -5, saying that it can't really be -5. But x can be bigger than -5. So that means it can be -4 and -3 and -2 and -1, etc., etc. But it can be everything in between too. So instead of highlighting each dot, I just shade in the whole number line. And you'll find quicker ways to do it than I am right now, but a highlighter would be great, wouldn't it? Like this. Oh yeah, that's much better. Okay, but the key here is that you have an open circle on -5, because an open circle means that -5 is not included. Okay? All right, now if I look at the one below it, I've got x is less than or equal to 1. Okay, so let's think about what that could be. Can x be 1 if it's less than or equal to? Yes, because it can be equal to 1. It's less than that, so 1, 0, -7, -10, etc. Okay, again, my best way to write that is using algebra or drawing a picture. So I only have my one number line here. So let's get this gone. And I'm going to show you, what do you think we're going to start at? We're going to start at 1. And we're going to start at 1, but are we going to include 1, and how would we do it? Well, you do flag it with a point, but this time instead of an open circle, we actually fill in the circle on 1 because 1 is included. That's a very large circle. I would hope that you would maybe make a little smaller circle. But then it's, of course, 0, and we said -7 and -10, so it's everything going this direction. And again, I'm going to use the highlighter because that's a lot easier. So I do a closed circle, and I shade in the line using that didn't come out as well as I would have liked, but okay. And I do the arrow as well, showing that it continues on in that direction. Please notice that you could use a highlighter is fine, but the closed circle is key. So here I'm using a closed circle to show 1 is included. Okay, so x is greater than 5 would be an open circle. X is less than or equal to 1 would be a closed circle. Okay, and if I in fact go back to my first page, if I were to graph anything that was greater than, it would be an open circle, and then the proper direction. Less than, it would be an open circle. Less than or equal to would be a closed circle because it includes that point. Greater than or equal to would be a closed circle because it includes that point. So x is greater than 2, that would have been an open circle moving this direction. X is less than or equal to 6 would have been a closed circle moving that direction. Interesting. Okay, now there's one more difficult topic that's a little more complex, and that's called compound inequalities, and there's my fox. So if I have a compound inequality, that means I have two different parts. I'm saying that x is smaller than or equal to 5, but x is also at the same time larger than -1. So what you do is you just look at these separately. Look at this one first and look at this one second. So if x is smaller than, notice the small side is closer to x. X is smaller than or equal to 5, or 5 is greater than or equal to x. I'm going to find 5 and I'm going to put a closed circle on it because it can be 5. But x has to be smaller than that, so it's going to be moving this direction. Now, if I just had that part, it would go all the way to the end of this number line. But because I have this part, I have to be mindful that it has to be both of these things at the same time. So x is also greater than -1. So where's -1? It's right here. And is that going to be an open circle or a closed circle? An open circle. And if x is greater than -1, it's going to move this direction. And guess what? They're going to collide, and that's the point. This is a compound inequality, meaning we're putting the two parts together and we're showing their overlap. So this shows me that these are the 2 points that would make a picture of this compound inequality. Okay, there are many more. There are some that will extend this way and have nothing overlapping in the middle. That would look something like this. Let's do it in a different color. If I had y is less than or equal to -8, but at the same time greater than 9, let's look at these separately. this part here, y is bigger than 9. So let's find 9. It's an open circle, and y is bigger than it, so it goes this direction. Now I look at this part, y is less than or equal to -8. I find -8, it's going to be a filled in circle, and y is smaller than or equal to 8, so I move this way. So the red shows this compound inequality. So these are more complex, but in this chapter, you're going to only be practicing getting used to the terminology and how to graph it. And then we'll be working on more complex ones in the next unit. But I leave you with this thought based on my friend at the bottom.